In this video, we are going to prove four important logarithm properties. The first is the change of base, second is the product, then the power rule, and the quotient rule. Memorizing and seeing how to use these is a separate topic, but in this video, we are going to prove them. Okay, so there's a little trick for the change of base formula, and at this point, you should know how to rewrite a logarithm, but if I let this logarithm base b of m just equal some variable, we'll just say x for convenience, then I know that this is equivalent, I'm gonna be flipping through colors here, to just saying that b to the x equals m, right? Now that is simply like definition of a logarithm. A logarithm by definition is the base raised to some power, which is the other side of the equals what you're taking logarithm of, the variable m in this case. Likewise, another way of thinking of this is if I wanted to get rid of this log base b, often teachers will say, so we're making b the base and everything else becomes the exponent. Okay, and because b to the log b cancels and we get m. All right, either way, but I know by definition, right, definition of a logarithm, that's what that means. So now what we're going to do is we're actually going to take the logarithm of both sides. All right, so I'm going to give myself a little bit of room and write this on the next line. Now, why are we doing this? Because in order to remove an exponent, right, in order to bring this x down, what I need to do is take logarithm. So we're going to do logarithm. Now you could choose any base. I'm choosing a only because in the formula it has an a. Most often we'd actually use natural log. Okay, we would natural log both sides. But for this formula, the base doesn't matter. Remember that natural log really just means log base e, right? So that's why that's easier to write and more frequently used. But anyways, log a on both sides. So then we could bring down this x times log base a of b, and the log base a of m. Well, we're about complete here. I need to solve for x, right? So I'm going to divide this on both sides. Log base a of b, log base a of b, and you could see we have what we originally were shooting for, right? The right-hand side of our proof of our formula here, this is our goal. My goal is to end here, right? I want to start here and end there, and I did. The only weird trick is I introduced this new variable x, which we stated at the beginning, right here, was log base b m, and now we ended with log base a of m, log base a of b. Done. We proved the change of base formula. And essentially the change of base formula says you take any log of the big number here, right, of over log of the base. All right, product rule. Oftentimes we don't write parentheses here because it's implied. If I have log base a mn, that means I am multiplying mn and it's log a of all of it. But let me go ahead and write the parentheses. And it says then that is equivalent to taking the log of m and add the log of n. So memorizing this formula is important, but in this video again, we're going to look why this is true. Okay. And I think from there, once you have the formula memorized, quotient rule kind of makes sense. If you multiply, you add, right? So if you divide, you subtract. All right. Anyways, we're gonna do a little trick here, and um, just like the first one, what I'm going to first say is that we will make this log a equal to some x, and this log base a of m equal to x, and log base a of n equal to y. Okay, out of convenience, just like we did for change of base. So on the side here, if I said x is log a of m, then I know that that is equivalent to saying a to the x equals m, right? Again, definition of a log. But if y is log base a of n, then likewise we could say a to the y equals n. Those are both, again, just by the definition of logarithms. Okay. So why is that important? Well, if we look on the left side, because this is what we're starting with, right? This, again, the right side is our goal. I hope to end with this. So I'm going to start with log a mn, but we know m is a to the x, so I'm gonna make that substitution here, and I know n is a to the y. All right, so I substituted these two for the results we had to the right. Oh, and one little thing I forgot is it's still base a, right? I'm so used to using logarithm or natural log that I forget the base sometimes, but it is base a. Okay, so now we get this is equivalent to log base a. Well, when we multiply variables with exponents, we could add the exponents. So this is a, I could add the x plus y, right? That's just the old rule of you have the same base, add exponents. Well, now we know that log base a to the a cancel, right? Because really, think again what a logarithm means. This piece here says, oh, let me do it in green, because I'm going to do some work off to the side. That says a to some power equals a to the x plus y. Well, the only way that could be true is if that box is x plus y, right? So therefore, I know the log base a cancel, and I get only x plus y. Well, thinking back to the start, it was a little trick, right? But we manipulated this to get x is log a of m, and y is log a of n, right? That was over here. That was actually the initial substitution we made. But that was our goal. We're done. Okay, in a tricky way, we just set those two beginning log base a of m and n to x and y, use some tricky algebra and substitutions to simplify, and done. We have the product rule. All right, moving forward. And by the way, there are other proofs. These are the ones that I know of and I'm aware of, and so feel free if any of this is confusing to look up other proofs. Okay, product rule for logarithms. Okay. All right, once again, this is our goal. Here's how I like to do this one. We now have product rule, okay? I know if I multiply two values in a logarithm, that is equivalent to addition. So what I'm going to do is take the start, a to the mp, and I'm going to say log a. M to the p power simply means take m times m times m, right? I don't know how many times exactly because I don't know what p is. But I can say that I know that there are p of these, right? P times. For instance, if we had like 3 to the 5th, I would know it's 3 times 3 times 3 times 3 times 3, right? 5 times. So because I have a variable p, I don't know what p is, but I know I'm multiplying it p times. Which then by the product rule, I could split this up as log am plus log am plus log am, right? They're all the same. How many times? P times, right? I have p m's there, so I have p additions. Well, repeated addition is equivalent to multiplication. So if I'm taking this number p times, then I have p multiplied by log am, right? Say I had 5 of them, then I have 5 times log am. I don't know how many I have p, but I'm done. By the way, this little 2/ thing means like I'm done with what I was trying to show. Okay, my proof is complete. All right, quotient rule. Now that we have power rule, I purposely did quotient rule after, and many authors will do this. It's because I'm going to take what I'm beginning with, m over n, and rewrite that as m times n to the -1. Because remember, a -1 exponent, like x to the -1, means 1 over x, right? So n to the -1 means I brought it down to the denominator. Or I could bring the denominator to the numerator and tell it to the -1 power. Again, I'm going to do parentheses here because it's log a of all of that. Now we're combining two rules. I know one rule I have is if I have multiplication, right? If I have multiply, I could change that to addition. So I could do log am plus log an to the -1. Maybe I should have did this in red. That's okay though. Right, that's what I did so far. I changed product. I used the product rule to change to addition. But now I'm going to use the power rule to bring this -1 down. Well, -1 times log an, I don't really need the -1, right? -1 times anything is just negative. And therefore, I'm done. I have my goal. This is the easiest, but it's because we had to do the grunt work to build up to that one, right? I needed product rule and I needed power rule in order to combine those two rules and use the quotient rule.